Good afternoon, friends. We will continue with yesterday's session of shape factor. Now you might wonder, why do we need this concept of shape factor and what exactly is this shape factor? Now yesterday in last session we have seen shape factor for a rectangular cross section. Correct? How much was the ratio for the same? I think it was 1.5. What was in the numerator? In the ratio of shape factor, ZP. What is ZP? Plastic section modulus. And in the numerator it was elastic section modulus. It means plastic section modulus upon elastic section modulus. This ratio is 1.5. In other words, it is also, we can say that plastic section modulus is 1.5 times elastic section modulus. Means what? If you carry out plastic analysis of the member, you will find that capacity, moment resisting capacity of the section, of a section which is carried out using plastic analysis, is more than 1.5 times. Okay, it means plastic sections will be more capable of resisting moments as compared to elastic sections. So that is the significance of shape factor. Okay, so yesterday we have seen shape factor for rectangular cross section. Today we shall see it for circular cross section, another symmetric cross section. So shape factor for circular cross section. Okay. So let us say we have a circle of diameter d. Okay. Here is the diameter of the section. Since the section is symmetric, elastic neutral axis will coincide with plastic neutral axis. So this is d by 2. Okay. Now as per the definition from yesterday's session, we have shape factor is equal to S is equal to plastic section modulus ZP divided by elastic section modulus ZE. Now finding out elastic section modulus is simple because we have already seen this in strength of materials. So ZE is nothing but I upon Y max. Okay. What is I? Moment of inertia for a circular cross section. It is pi by 64 d raised to 4. Okay. And what is Y max? Y max again same to yesterday's rectangular cross section. Y max is centroidal distance of extreme fiber from neutral axis. So d by 2. So you will get this as pi by 32 into d cube. Okay, so this is ZE. It is over. It is very simple. Now plastic section modulus. Again you recall yesterday's question of rectangular cross section. In that we have said that ZP is AC into YC plus AT into YT. Okay. So again, area in compression zone and area in tension zone is same, equal, which will be half of the complete circular area. What is the area of one circle? Pi by 4 times d square. So its half value will be pi by 8 times d square. So area in compression is pi by 8 times d square into YC. This is somewhat tricky. You must remember what is centroidal distance for semicircle. Now where is the centroid? Here. So you need to find out centroidal distance of compression zone as well as tension zone from neutral axis. So this is YC. YC is nothing but 4R upon 3 pi. Okay. So I will write here 4R upon 3 pi. this is yc, and this is yt. Yt is also same, and at is also pi by 8 times d square. So pi by 8 times d square, because it is half the area of the circle, into again yt is 4r upon 3 pi. So you take now pi by 8 times d square common. So inside the bracket it will be 2 times 4r upon 3 pi. So what will be here now? The adjustment to be done. This 2 and this r. 2r is 1d. Okay. So 5 by 8 d square into 4. This 2 into r is d upon 3 pi. So this pi value gets cancelled. This is 4 getting cancelled. This becomes 2. So d square into d is d cube divided by 6 pi. Correct? Sorry, not pi. D cube divided by pi only. Okay. D cube upon pi. Now both z values are in terms of d. Pi is constant anyhow. So shape factor S is equal to Zp. How much is Zp? D cube upon 6 divided by pi by 32 into d cube. So this d cube gets cancelled. 32 goes to the numerator, divided by this pi is as it is, multiplied by this 6 is in the denominator. So 32 has gone to numerator. So 32 upon 6 pi, you calculate this value, it comes out to be 1.698. 1.698. It means if you use a circular cross section, so for plastic analysis, Z value is 1.698 times value of elastic section modulus. That is, value of plastic section modulus is 1.698 times elastic section modulus. Okay. Now we shall see one unsymmetric section. Okay. Till now we have seen two symmetric sections. One is rectangular and second is today's circular cross section. Now we shall see a triangular cross section. So now we shall start with the triangular cross section, which is not symmetric. Okay, so let us draw this triangular cross section first. Okay, so we shall assume that width of this cross section is small b and height is small h. So b by h. Okay. Now again, shape factor ratio is Zp upon Ze, wherein Ze elastic section modulus is I upon Y max. So here carefully see I value, that is moment of inertia for a triangular cross section, is Vh cube upon 36. Okay, divided by Y max. Y max is centroidal distance of extreme fiber stress. So if you assume that CG of triangle is here, so here is the base, here is the apex. So from apex it is 2/3 of height. Okay, so this is 2h by 3. So how much will be this? This 3 will go to numerator. So 3bh cube divided by 36 into 2 is 72. So this will become BH cube upon 24. So elastic section modulus for triangular cross section is BH cube by 24. Now, since triangular cross section is not symmetric, elastic neutral axis will not coincide with plastic neutral axis. It will be somewhere else. It will not be at 2h by 3 from apex. No. So we will assume some arbitrary depth of plastic neutral axis. We shall assume that it is at a height of h1 from apex, and corresponding to this h1 we shall assume that width of this triangle, which triangle here, the upper part, is b1. Okay. Now as per the theory or the assumptions, area above the neutral axis and area below the neutral axis both are equal. Okay. It means whatever the total area is there, how much is the total area? Since it is triangle, half base into height. So area of triangle is equal to half base into height. Now we shall assume any area that is either above the neutral axis or below the neutral axis. So I have considered above the neutral axis, which is in compression zone. So area in compression zone, since both are equal, it means area in compression zone is half of the total area. So half of total area is half BH. Okay, so what we can say is AC is equal to half times A. AC is equal to half times A. Okay, so now we will use the similarity of triangles. So what is similarity of triangles? B1 upon B is equal to H1 upon H. From this we will get B1 is equal to B H1 upon H. So we will continue with this. Now compression area is half of total area. How much is compression area? Either this or half B1 H1. That is what we have said. Area in compression zone half B1 H1. Okay, it is equal to half of total area. So in this we will substitute B1 by this value. So what will become? 1 by 2 into what is B1? B times H1 upon H into H1. It is equal to 1 by 4 into BH. So now we shall take 1 by 2 times B common and we will delete it from both the ends. So half B is gone. So H1 square, because here is H1 into H1, we will take this H on right hand side. From this 1 by 2 B is over, so 1 by 2 remains into this H into this H square. So in short we get H1 is equal to H upon root 2, 1 by root 2. So H1 is equal to H by root 2. We will substitute here. So B1 upon B is equal to H1. H1 is H upon root 2 divided by h. So what will we get? This h gets cancelled. It will be 1 by root 2. It means from this we are getting b1 is equal to b upon root 2. In short, we have got h1 in terms of h as h by root 2, b1 in terms of b as b by root 2. So proportionate. Now we will go to plastic section model ZP. It is equal to AC into YC plus AT into YT. What is AC? Half B1 H1, okay, or 1 by 4 times BH. And before that, we need to find YC and YT. Instead of AC and AT, which we already know, we will first of all find YC and YT. So what is YC? What will be YC? YC will be centroidal distance of this triangle from plastic neutral axis. So this is 1/3 from the base and 2/3 from the apex. So we want from this. So this is the base. So from base 1/3 of h1. h1 by 3. So what is h1? h1 is h by root 2. So h upon 2 root 3. What about yt? Yt is a little bit complicated. Yt will be h minus h1 upon 3. You try to correlate this to the diagram. H minus h1, it means this height, upon 3 into b1 plus 2b divided by b1 plus b divided by b1 plus b. Now this is centroidal distance formula for trapezoid. Okay, this is centroidal distance formula for. So this is centroidal distance formula for trapezoid. Okay, now we will substitute one by one the values. So h minus, what is h1? h1 is here, h by root 2 divided by 3 multiplied by b1. What is b1? b1 is b by root 2 plus 2b divided by, again b1 is b by root 2 plus b. Now you simplify this. What you will get is yt in terms of h as 0.1548 h. Okay, since this is algebraic parameter or algebraic step that we need to carry out, I will not go into details because that is simple. So this is yt. Now we need ZP. So what is ZP? AC into YC plus AT into YT. What is AC? A by 2, which is common because here we are going to write A by 2, here also A by 2. So A by 2 into, what is YC? H upon 2 root 3 plus YT is 0.1548 h. So what is A by 2 now? A is half base into height upon 2. So this is 1 by 4 BH into this value. How much is this value? you find out. Okay, h upon 2 root 3 plus 0.1548 h. Now you simplify this. This will be with some coefficient into h. So h into h is square. So bh square into some coefficient divided by 4. This totally is finally 0.097. 0.097. Let me check it. Yes, it is same. 0.0976. BH square. So ZE is BH cube and this is BH square. So BH cube, it is not BH cube, it is BH square. I am sorry. Let us correct it here. Because this is h cube, this gets cancelled with one of the h, so this is h square. Okay, fine. So substitute these two, zp upon ze. What is zp? 0.0976 bh square divided by bh square upon 24. Take this 24 to the numerator. So 24 into 0.0976. See how much is this product? This product comes out to be 2.349. 2.349. BH square is common, so this gets cancelled from the numerator and denominator. So we have seen how shape factor for an unsymmetric cross section is to be calculated. So for triangular cross section, shape factor is 2.345. You please remember, for each and every cross section, shape factor is a constant. It does not change. Whatever may be the size of the section, shape factor is constant for any particular cross section. It does not change. It is constant. Thank you.